So now that we have a little bit of information talking about molded parts, let's get started by talking about drafted part design. Now there are several things that we need to be aware of when we get started, and as with all the other videos, we really want to start with the basics, a base foundation, so we're building from the right place. So the first thing I want to do is I want to start a new file, and I'm going to use part inch template. Now inside here, the first thing I want to do is go to Tools, down to Equations, and I'm going to start creating some global variables. The first global variable I'm going to call draft, and I'm going to set the value to 3. Now 3 is an arbitrary unit. It's not 3 inches, it's not 3 degrees, it's just 3. So when I use that value as a dimension, for instance, for the draft of a wall, it's going to use as 3 degrees. If I try to use that value for a distance, it's going to be 3 inches or 3 millimeters. So it's very handy to have this sort of global variable in there for draft, and the base of the file we can come in and we can change whatever we want our standard draft to be. Draft is very important because when you start designing your parts, it's going to affect everything. Now, if you have a very big part, something that's considered a deep draw into a mold, you're going to have ample draft to associate with that. If you have a very thin, very small part, you can get down to 0.5 degrees, 1 degree draft and be okay. Sometimes you can even get away with no draft if you understand that you're going to have tool drag marks on the outside of your part. There are also things to consider like texture. If you're going to have a heavy texture on the outside of your part or the A side, you're going to have 3 to 5 degrees draft minimum. So it's always a good idea to, again, consult whatever company you want to use to create your short-term or your production molds and figure out what their limitations are, what their requirements are. It makes it much easier. And also setting up your equations and things like this, it's going to be much easier for you to go back and change those dimensions globally. If you design your parts and everything is linked back to this original draft number, you only have to change it in one place. You don't have to go back and figure out dozens of different features, dozens of different sketches, and different entities where you have to go back and define this. So moving forward, there are really a few other things that we must know as we're going through. The first is going to be wall thickness. And I really like to set this, and I'm going to set it at 0.1. It's rather thick. We're not really concerned because we're not physically making a part. But that way I have a nice number that I can use, and the next part makes a little bit more sense. Now, whenever you're designing a molded part, and again, this is theory that you're going to have to know once you start to go forward and design your own molded parts, but just for the purpose of our video, I want to make sure that you understand what we're doing here. When you design a molded part, the outside of the part is going to have a consistent wall thickness. That's extremely important that the wall thickness is consistent throughout your part. But when you have internal walls, things like bosses for screw holes or where you're threading into them, or if you just have structural ribs on the inside of your part, they cannot be the same wall thickness as the outside of the part. Otherwise, you get things called sinks on the outside. These are areas that are thicker and they cool at a different rate. And what you end up getting is an indentation on the outside of your part or the cosmetic side. I'm sure if you go around, you look at all the different plastic parts you have, especially older plastic parts, you can see these imperfections where on the outside of your part, you'll notice exactly where all the structural ribs are. You see these in things like older flat screen TV cases or even older kitchen appliances. Anytime that they made a very thin wall outside shell to a part and they realized that they couldn't put structural ribs that same thickness, they end up getting those imperfections on the outside of the part. So what we want to do here is we want to create a value called ribs. And this value is going to be linked to our global variable for wall thickness, and we're going to multiply it by 0.6. Now, 0.6 is going to be 60% of the original wall thickness we enter. Now, that is the low end of the spectrum. Typically, you're going to be between 60 and 75% for the wall thickness, but again, it depends on what your major wall thickness is, and it also depends on the type of plastic you're using, the size of your part. There are a lot of different variables that you need to consider. But for our example here, draft set to 3, wall thickness at 0.1, and the ribs set to be 60% of the original wall thickness, we have some nice round numbers. Now the reason this is so important is because at any point in time we can come back to this file. Let's say that we wanted the wall thickness to be 1/8 of an inch. It automatically updates our ribs, and everything in the file that's linked to these values is going to update as well. So we're going to say OK, and remember we're still on a blank part. The next thing I want to do is go to Save As, and I'm going to change it to be a part template. Now inside here, this part template is going to be called part_inch_drafted. Then we're going to close this out, and we can start a new file. Now as we look in here, we now have a part inch template. We have a part inch template drafted. So when we say OK, we already have equations in here. We can right click and manage those equations. We have draft, wall thickness, and ribs. This is a great starting point for moving forward with our drafted parts. And of course, these values are arbitrary. We don't have to use 3 degrees draft. We don't have to use 1/8 of an inch wall thickness. We don't have to use 60% for the ribs. But these values are here. They're already linked inside of this part template file. We can come back and we can change them and have the foundation that we need for our part. Now to talk a little bit more about drafted part design, we need to open a file. So let's go ahead and open up Mold Tool example that's provided with this course. Now this Mold Tools example file was one that was used during the Mold Tools course on the O'Reilly website. What we have here is a plastic part, and we created the entire mold for it. And the reason I use this part as an example is because it gives us a great base to understand drafted parts. So the first thing I'm going to do is I'm going to roll back the tree up above the 2 body move copy operations. Then I want to take a look at a section view. Now for my plane, I'm going to select my right plane and say OK. Now if we view this from the right plane, you're going to see some overlapping areas. So what I want to do is go back up to my solid bodies folder, and we want to take a look at the file parting line 1, and we're going to hide that. Now when we hide it, we now see the core and cavity areas of our mold. Now the core area is going to be the inside of our part. The cavity area is going to be the outside or the cosmetic side. When you're dealing with drafted parts, they typically call these the A part or the cosmetic part and the B part, which is the inside. Now there are a few things I want to mention here or really want to talk about. Now the first thing I want to mention is the draft. Now the draft on the inside of the part and the outside of the part has to be oriented in a way that you can pull this thing out of a mold. Now there are some instances in this file where we have things like overhangs or underhangs. Now these are areas that cannot be pulled out of the mold, but that doesn't mean that you cannot create your parts like that. What you can do is you can have things called cores or side pulls. Now these are separate pieces of the tool that can be pulled out before the top and the bottom or the sides of the mold are separated. Now these give us a little bit of flexibility in designing our parts because we can add in features and detents and things like that that otherwise would be impossible for us to make. So you can see here in the mold, as we rotate it around, that area that was an underhang or an undercut is an area where this thing maybe needs to snap into another part. And we can use what's called a core body. And you can see this core body here is a separate piece that gets pulled out before the rest of the mold is disassembled. So now that we understand that a little bit, let's take a look at the rest of our parts. We're going to hide the top, and we're going to be taking a look at the core portion of our mold. Now, as we look at this mold, we have things like little pins, and these are holes for a speaker. Then we have areas where we have these slotted bodies, and these are areas that are vents for possibly a fan inside this housing. Now, these all have to have draft on them. Now, when I say they have to have draft on them, as we look down at this from the top, if we zoom in, you can not only see the top face, you can also see all the side faces because they have draft on them, and that gives us an easy way to remove the top of this mold. So that way we don't stick or grab onto the mold. If we look down at these bosses, you can see that's the exact same thing. We can see the top of the boss as well as the side of the boss. So that tells us that we have draft on all these faces. This goes for every part of your mold. These deep channels on the side here, even though they go down pretty far, they all have draft on them and they're all able to be pulled from the mold easily. So these are the types of things that you need to consider when designing your part. And moving forward, we're going to talk a little bit about different ways that we can design, whether we're starting with a draft or whether we're designing and then we're drafting after the fact. There are positives and negatives to each of those, but it's a good idea for you to open this file, take a look at it, and play around with it and just see the different areas that have draft, the different areas that don't possibly have draft, like the sides on the outside body, and that way you can get a little bit more of an understanding as to what each of these are. So take a look at the solid body parting line 1, which is the final body that we're trying to create, and get a look at all the different features and notice that they all have draft on them, even though there are some complex features.